all hear me nicely?
Yes.
Yes.
Okay, great. Okay. So let's start. Let's see. So we're going to start with Amaro's question now. The first question using first principles, I've made a video on that question that I've sent to the group. This is actually from the concept videos, 2 over x. So you guys can go through that. So this question is asking you to find the derivative. Now, Tyler, have you guys done calculus yet at South Peninsula?
No, we have not. I'm looking at this and I'm just like, okay, then.
Yeah, no, it is very daunting. Ask Naima when she also didn't do calculus. Naima, I remember a couple of weeks ago, it is, ask all of them, just tell Tyler that when you first saw it, it does look very daunting, right?
Yeah.
It does look very,
Yeah.
It gets easier.
it looks daunting at first, but I promise you, I want you to watch the concept videos on calculus, Tyler.
Okay, I'll do that.
There's like 9 of them, and if you go through them and watch them, watch them well and ask questions, you'll start making sense. So if it doesn't make sense now, it's fine because you haven't learned the concept yet. But maybe just sit back and then maybe you watch the concept, and then you can even come back to this question. Okay.
Okay, well, thank you.
Okay, so this is asking for the derivative. So the first step in the derivative is that before you can take the derivative, you have to write it in a form that is, it's in a nice form. So when they write it as a square root, like that's not a nice form, right? Do you guys agree? How can we change this into something nice? You guys can answer.
2 over 3.
With x to the power of 2 over 3.
Right, you can change that to x to the power of 2 over 3. And the second term, how can we change that?
We bring the x to the top, so
Yeah. So what's it going to be?
Power of -4.
1 x to the power of -4 over 4.
Yeah, I prefer just to do a quarter x to the -4. It's a bit easier. Do you guys all agree?
Yes.
Okay. So now we can take the derivative, and the rule of the derivative is, of course, we mentioned that you multiply by the exponent and you subtract the exponent by 1. It's as easy as that. So you multiply, so it becomes 2 over 3x. And 2 over 3 minus 1 is?
-1 over 3.
Right. And then you multiply by this exponent and it becomes?
-1.
X to the -1, x to the?
-5.
Right, that's f dash x. Anybody want to explain to me what is the derivative? How would you start, like if I asked you English questions, so you guys just came from English now. How would you explain in nice English what is the derivative?
The derivative is the gradient.
It's the gradient, okay. But I'm not even like, that doesn't look like a gradient to me. I mean, it looks very like, I'm used to like a gradient of 5, 6, 2.5. That looks very weird. So like, can you just explain that to me again, please? I'm just playing. So how would you explain, like, why are the x's there?
If you start in the x value, you'll get the gradient at that point.
You guys will get that? Correct. So if I were to ask you, is the gradient constant in this graph? You guys can just shout out. Is the gradient constant?
No.
No. So that's why you have it in terms of x. So if I asked you what's the gradient when x is 6, then you sub 6 into this equation, right? You sub x into this 6 into this equation. So all this derivative is that it's telling you the gradient at a point. Okay. Next question is quite interesting. Amara, did you get this one? After I showed you.
Oh yeah, I got it.
Okay. But just for the others, notice how they write here dx by dy. What do you think that means? You guys are used to dy by dx. What is dx by dy? Ayan, do you have any idea?
Is it in terms of y?
Yes, yes. So the change in x with respect to y. So what does that mean mathematically? What must you do?
So we
Make
have to
y.
make the
Okay,
subject.
Ayan.
That's
Amaro,
fine.
no, I want to.
Make y the subject of the formula.
Well, remember we make y the subject if it's dy by dx.
Make x the subject of the formula.
But because it's dx by dy, you make x the subject of the formula. You guys will see that.
Yes.
Afisa? Afisa? Rivka?
Yes, I get it. Yeah.
Okay. So how can we make x the subject of the formula? Can become 27y equals x cubed, right? And then x equals 3y to the power of a third. If you just cube root each of these, becomes 3y to the power of a third. So what's dx by dy? What are you gonna do?
We
Rishka,
times
what
the
are you
third
gonna?
by
Yeah, Ayan, you see it?
we times the third by the 3, then we minus the 1.
So what's the final answer?
Y to the power of -2/3.
Right, because you multiply by the third and it becomes to the -2/3. Okay. So do you see, this is just mathematics language, but all they're saying is make x the subject of the formula and take the derivative. Okay. Next question. X cubed minus 3 squared. So what are we going to do first? What did we say? What's the first step before you take the derivative?
We fold it up.
You FOIL it out. So what's it going to become? So it's x cubed minus 3 times x cubed minus 3, right? So what's the FOIL going to give us here? Nafisa? Nafisa, can you guys hear me?
Oh, sorry. Yes.
Yes.
If you FOIL it out, then it's going to be x to the power. You times it, right? So it will be x to the power 9, then minus 3x cubed, and then
So it's x cubed times x cubed, right?
yeah.
So when you multiply the bases,
Or you
what
add
you-
the exponent.
if this was x cubed,
Then it would be
then
9.
because what does this mean? That means this. Do you see?
Mm-hmm.
Whereas x cubed times x cubed is that. Okay, so what is the x to the power of 6?
6.
Right. Okay. And then this one, the middle terms.
Then you will get minus 3x to the cube,
Mm,
and then minus 3x cube again, and
so it's
then
minus 6x cubed.
yes, and then you get plus 9.
Right. So all we've done is we've just expanded it, right? We haven't found the derivative. Do you guys agree? We haven't found the derivative. We just made it look nice. Just made it look nice. So now we take the derivative, because now it's no longer dx. This means derivative of, now we say that's equal to. So what's the derivative? Rivka, you want to try?
6x to the power 5
Yeah.
minus 18x to the power 2 plus, no, just, that's it.
Yeah, great. So you guys all happy? Is anybody unsure? Amaro, you asked the question, so which part were you unsure about? Amaro?
It's just the first one.
Oh, just the
But-
first one. Okay. I mean, you mean the first one as in 2 over x? Or this
No,
one?
1.2.1.
Okay, okay. But does it make more sense now? Do you see, just write it as x to the 2 over 3 and a quarter x to the minus 4?
Yes.
Okay. So we can move on to the next question. Okay. So the next question, okay, this looks similar. Okay, do that. Copy and paste. Okay. So a point 1, 4, this is also a calculus question, is a turning point of the function ax cubed minus 6x squared plus 9x plus b. Show that a equals 1 and b equals a. So this question, guys, we've done it a lot. And I want somebody to tell me what is the approach to this type of question. Anybody? Naima, what's okay? Rivka, what's the approach?
No, it's fine. That's fine. That's fine.
Okay, Naima.
Isn't you said you must find 2 pieces of information?
Yes, and how do we? And what are the 2 pieces of information in this question?
So the one is the turning point, and the other they give you the equation. Okay, but that's not really helpful.
See, so the equation isn't really the piece of information because you
Yes.
you want to. So the turning point is the one piece of information, but what's the other piece of information? Anybody else want to help her? Ayan.
We are given the function.
You're given the function, yes, but you want to use something else so that you can put into this function.
Isn't it they give you the point, but that point is a point and the bounce point?
Yes,
Isn't
but not bounce point. Remember what? Don't
The
use bounce point.
the turning
Yeah.
point.
What's the bounce point again?
It is
Wait.
one of the points in the x intercepts, which is also a turning point.
Yeah. So if you have a graph like this, and it does that, so you see the x-intercept is also a turning point. That's called a bounce point because like it's bouncing off the x. It's like a ball that's bouncing off the chips, and then yeah, okay. So Nafisa is right. I think it was Nafisa who said that the turning point is always 2 pieces of information, guys. the turning point is always two pieces of information. Why? Firstly, it's a turning point. And you know in calculus, what do you guys know in calculus about the turning point?
The gradient.
What about the gradient?
It's equal to 0 at the turning point.
Yeah, so it doesn't say the gradient because the gradient changes, right? So at the turning point, the derivative, or g dash x, because this function is g of x, g dash x equals naught at 1, 4. And Nafisa also said that 1, 4 is also a point in this function. So can't we just sub in 1, 4 into here? You guys see? Guys?
Yeah.
Okay. So if you sub in, what do you get? You put the y value of 4 equals a times 1, which is a, minus 6 times 1, which is 6, plus 9 plus b. So if we simplify, we can take the 6. So this 9 plus minus 6 is 3. So if we take the 3 over, it becomes 1 equals a plus b. Okay?
Yeah.
You guys must just, I want to have rolling commentary. I don't want to be the only one speaking, because it's not, if I speak, then I assume that everybody understands. So I really want you to stop me if there's anything that doesn't make sense, okay? Even if you just say yes, 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 then at least I know, because I can't see you. Obviously, I can just hear you. So if I see you, then I can be like, okay, I can see that you understand. But if I can't see you, then I need you to tell me, okay? So do you see
Okay.
how just from subbing in the point, you get one equation? But this one
Yes.
equation is not enough because it's two variables. So that's why you need another piece of information, which is the fact that this is a turning point. And you told me that the turning point is where the derivative equals naught. So can't you find the derivative, put it equal to naught, and then sub in the values of x, which is 1, 4, and then you can find a and b. So if you find the derivative, it becomes what? It becomes g dash x becomes 3ax squared, right?
Yes.
Minus 12x
Plus
Plus
9.
9.
and what happens to the b?
It falls off because it's a constant. So it's
Correct.
0.
So we don't know what b is, right? But we know it's a number. So it's a constant that we just don't know the value of. It's not like x and y which change, right? It's just a number that we don't know. It's one number. It's a constant. We just don't know the value of the constant. You guys see that?
Yes.
Yes.
Okay. And we're saying that this g dash x equals naught. But when x is what value? When x is
1.
1. So that means that 3a, if we take it over to the other side, minus 12 plus 9 is minus 3, right? So 3a equals 3a equals 1. And if a equals 1, then what does that make b?
Equals to 0.
0. And that's what they wanted you to show. Okay. So do you guys see the approach is the same? Naima, do you see the approach is exactly the same? If they want you to
Yes.
show that A equals something, B equals something, you ask yourself, I need two variables, so I need two pieces of information. If I have two pieces of information, I can create two equations. Here's equation 1, here's equation 2. And because I have two equations, I can simultaneously solve for the two variables. It's exactly the same. So that's easy 4 marks. Okay. Everybody happy?
Yes.
Yes.
Okay. Thanks for being so responsive. Okay, so now it says determine the x-intercepts. How do we determine the x-intercepts? Oh, so Nafisa is going to do it using synthetic, and I'm going to. Okay, which method do you guys use for cubic? I know Nafisa and Amaru use synthetic. Ayan and Naima and Rivka, which one do you use?
Don't we let y
I
equal
use
0?
later.
Rivka, what do you say?
Yeah, what's wrong?
So what do you use for solving cubic equations?
The what do you mean, like
Do you use synthetic division, or do you use the other one?
I think she uses the normal one. She was taught the normal one. We just found the synthetic one somewhere else, so we use it. We
Wait,
weren't taught that at school.
Oh, you weren't taught synthetic division at school?
No,
Oh,
I didn't
oh,
even
okay.
know the name until like last week.
Oh, okay. So we want the x-intercept. So what do? We make y0,
equals
right?
0.
So it becomes x cubed minus 6x squared plus 9x plus 0, which is just, yeah. So what's the first thing that we do when we're wanting to solve a cubic equation? What's the first thing that we do? Nafisa?
Oh, we're using my method. I mean, the
Both
synthetic
methods.
method. You find the factor. You find the factor.
So how do you find a factor?
You sub in 1, 2, 3, then you see what will make it equal to 0.
Exactly. And you guys, does anybody know of a factor? I can check quickly.
Yes, it's 3.
Great, so it's 3. So what we mean by, so technically 3 is the root, not the factor. Okay? The root is what you sub in. What's the factor if the root is 3?
Minus 3.
Minus 3. X minus 3.
X minus 3, not minus 3, x minus 3, okay? Because if we're factorizing, then it becomes x minus 3. Because what happens if we sub in 3 into this bracket? It becomes...
You get 0.
It becomes 0, yeah. So x minus 3 is the factor. But if I were to sub in 3, that would be the root that gives me 0. Okay. So I'm going to do my method, and then we can do synthetic as well. So the first thing I ask myself is, I need x cubed. So how must I multiply this x by to give me x cubed? I must multiply it by x squared. But that x squared is also going to multiply by this minus 3. But I need minus 6. So I need minus 3. So I've got minus 3 already. But I need another minus 3. So I can get that by writing minus 3x. Because if I write minus 3x, that gives me minus 3x squared, which gives me minus 6x squared. And then minus 3 times minus 3x is just 9x. Okay. So actually, guys...
What? I'm still... Okay, never mind. Sorry. Okay, bye.
No, don't say never mind. I can explain this again.
No, I get this method. I was still confused on what you were asking me earlier. It's fine.
Okay. Can we simplify the second bracket, guys? Can we simplify the second brackets?
Yeah. I
How?
think.
I
You
want
pull
to
out
say
X as
dots.
a common factor.
Can't you take out the x,
Yeah, it's a common factor. So
which leaves you with what's inside the bracket?
X minus 3.
So what does that mean? If this is
We
x
have
minus
found
3. Yes, who said it? Naima.
me.
Right.
Yes.
It's x minus 3 squared. And remember we said whenever we have a square, whenever we have a square in the cubic equation of a factor, that becomes a bounce point. Okay. So let's use synthetic division. Okay, Nafisa, we're gonna try synthetic. And guys,
Yep.
we've made concept videos on this, eh? If you want to revise, we made concept videos. So 3 is a factor. It's 1 minus 6, 9, 0. So then you bring it down. So it becomes 1. Okay, 3 times 1 is 3, which is minus 3. You add these, becomes minus 9, which is 0. And therefore you get x squared minus 3x, which is the same as what we got earlier, right? Okay, guys?
Yeah.
Okay.
Yes.
And there are concept videos on synthetic division. So what are the x-intercepts then?
X is equal to 0.
And
X is equal to 3.
right. And we said that not only is x equal to 3 the x-intercepts, but it's also a
Bounce point.
bounce point. Okay. So now it says the coordinates of the other turning point. Now they're telling you that 1, 4 is the one turning point, right? My question to you, what's the other turning point? What's the other turning point?
It will be the same.
What do you mean be the same as what?
So basically, because it's like you said, it's the bounce point. So the bounce point, it means that like the x will be 3.
Yes, yes. So do you see how you don't actually have to work it out? Do you guys see that?
Yes.
I told you that whenever there's a square of a term in the cubic function, that's by definition a bounce point, which means it's a turning point. And now the next question says determine the turning point. If they really gave you 1, then the other one by definition must be this one, by process of elimination. Do you guys see that? So in an exam, you could actually get all 3 marked because they're using the word determine. They're not using the word calculate, which means it doesn't really matter how you find it out. It's fine. But how else would you find it out? What's the turning point? What else could you do? What else could you do to find the turning point?
The gradient.
Work out derivative.
Yeah, and then you solve
I mean,
from derivative.
yeah,
You're all saying find the derivative, find derivative. But there's
So you make
something
the
missing.
And make it equal to 0.
Yes. So remember I told you when you wake up in the morning, there's 3 things I want you to say to yourself. The derivative is equal to 0 is the turning point. Second derivative equals 0 is the point of inflection. And the gradient of the tangent
is equal to the gradient of the graph at the point of contact.
There we go. Okay, there. You see that? That's what you must wake up every day, and those are the three things that you say to yourself. Okay. There's more, but that's really important. So when I ask you how do you find the turning point, I want you to say, Elias, derivative equals naught. Don't say derivative. Okay. Derivative equals naught.
Yes.
Okay. So what's the derivative? Quickly, who's going to do the derivative for me for this function?
3x squared minus 12x plus 9 equals 0.
Yeah. Okay, and then what can we do?
Trinomial.
But what's to make it easier? What can we do?
Divide by 3
Yeah, so it becomes
x squared minus 4x.
Or you can just use the formula, which is like so much easier.
I mean the quadratic formula.
Yeah.
No, but that's only for we don't cheat like that. Yeah.
But like I did now, and I will still get the same answers as you.
Yeah, but it's like you can use your own mind to find the answer without having to rely on the calculator. Believe me, right? Like sometimes I actually think we waste too much time on the calculator. That's why when I do my maths, if you get your mental maths strong, then you actually save time. So I only use I try to only use the calculator for trig, and that's pretty much it. So if you can train yourself to, because then you can actually become faster. Okay, so then this becomes x minus 3, x minus 1, right?
Yeah.
So what's the turning point?
3 and 0.
Huh?
No, 3 and 1.
Oh,
3 and 1. Who said 0? Do you see here it's 1, right?
Yeah.
Okay. So
wait, okay.
Question?
No, it's fine. I got it. I see now.
Okay. So 1 we expect, right? We expect 1, but we also get 3. But we predicted that it would be 3 because it's a bounce point.
Okay.
So this is just confirming. Like we already knew, we already suspected it, but now we're just proving it. Okay. Okay. So now they want us to sketch the graph. So who remembers the 3 things that I said you need to sketch a cubic graph? There are 3 things.
The shape,
Turning point.
First, what's the first thing? First thing.
the x
The
intercepts.
turning point.
The
Oh.
x-intercepts, or the intercepts, so the x and y intercepts,
Yeah.
right?
The
And then-
shape.
Then number 2,
Turning point, isn't it?
Shape.
the turning point.
I think shape was.
And
Oh.
then
And
number
then-
3, yeah. And then number 3,
Stationary points.
that's turning point.
Shape.
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 Okay. Spelling mistake. So we found the x-intercepts, right? We said they were
X is equal to 3.
and naught, right?
Yes.
And the turning points are 1 and
3.
3.
3.
Okay. Now the shape. So how do we do the shape again?
With the number line.
Right, we draw a number line. Great. I see you guys are getting the hang of it now. So and then what do we put on the number line?
If the
The
gradient
turning point.
or
Somebody said, what do we mark on the number line?
If it's
Yeah.
The
positive,
turning point.
Yes, turning point. So what are the two turning points?
so it's
One.
1.
3.
Yes. And then what do we do now?
We write if it's negative or positive, like the concave.
Yes. So you can sub in a value here, then you sub in a value here, and then you sub in a value here. So over here we can sub in naught, right?
Yeah.
But into which equation do we sub the?
The regional equation.
No, not the original equation. Remember, what
The
are we trying to
derivative.
find? What are we trying to find by this?
The
We want
shape.
the shape. The shape. Does the original equation tell me the shape?
No, the derivative does. So I'm gonna put it in the
Derivative.
derivative equation.
Right. So it becomes, so we said our derivative is 3x squared plus minus 12x plus 9, right? So when we sub in naught, what do we get?
9.
Which is positive.
A positive.
It doesn't really matter what the value is. It's more, is it positive or negative? Okay.
Yeah.
And then when I sub in between 1 and 3,
Negative.
Get negative.
and then greater than 3.
Positive.
So what's the shape of the graph? I want you guys to all draw it for me, and then you can check if it's right. I'll give you 10
Yeah.
seconds. You guys all drawn it?
Yes.
Yes.
Yes, yes.
Yeah.
Okay. So you guys get something like this.
Yeah.
Yes.
Yeah.
Everyone get that?
Yeah.
Okay. So now we have all the ingredients to making our to drawing our graph. Okay, because we've got the turning point, we've got the shape, and we've got the intercepts. Okay. So let's draw our number line. Okay, draw our Cartesian plane. Okay. Okay, our Cartesian plane. And we can just fill in our information, right? What did we say the x-intercepts are?
3
Right.
and
3. So we can say about over here. You can draw this with me, like a draw along. Draw along. Okay. And then the other x-intercept is?
0.
What's the y-intercept?
0.
Also 0, right? Because there's no constant. There's
yes.
no constant. Right. And the turning points?
It is 1 and 3.
3.
And what's the coordinates of the turning points? Remember, the coordinates are important also.
1 and 0.
No, not 1, 0. They told us in the question.
1 and 9. Oh, 1 and 4.
1 and 4, right? So they told you there, okay? So about here, do you guys agree? There's like 1, 1, 4.
Yeah.
And where's the other turning point? What's the coordinates of the other turning point?
1 and 3.
No, the other turning point. What's the coordinates of the other turning point? What's the coordinates of the other turning point? We said the first one is 1, 4, which is this one. And the other one is?
Isn't it 1, 3?
No, because the first one is 1, 4, right? That's the coordinates of the first one. And the second one we said
So,
is at 3. Didn't we say 3 is a bounds point?
Yes.
So what's the coordinate of the turning point?
Isn't it 3, 0?
3,
0,
0.
3.
3, 0.
0,
What's
3.
0?
Is it 3, 0, 0, 3? 3,
3,
0.
0. 3,
Okay.
0. Because 0, 3 is here.
Yeah.
Okay, so it's going to be here. And that makes sense, right? Because we said it's a bounds point. Okay.
Yes.
So we filled in the x-intercepts. We filled in the turning points. And we know the shape. So we can start plotting. So I want you guys to, I'll give you 5 seconds. Okay. Is everyone happy?
Yes.
And then just to prove it to all of you, this is a really nice website called Desmos. 1 minus 6, 9. Okay, so the equation of the is 1, y equals x squared, y equals x cubed, minus 6x squared plus 9x. Plus 9x. Down. Yeah, okay. Come on. Okay. Plus 9x. It's just taking a bit long. Plus 9x. Right, you guys see that?
Yes.
Okay, so you see how you can draw it without having to rely on anything else. Okay. See that? That's pretty much what we drew, right? You see that? It's exactly the same. Okay.
Yeah.
So now let's take that away. So what's the 3 things we need to draw a graph? A cubic graph. What are the 3 things?
Intercept
Turning point.
and shape.
One more time. Nafisa,
Intercept
say it.
and shape.
Nafisa, say it.
The intercepts and then the turning what? Yes.
And then
The shape. As the intercept, the turning point, then the shape.
okay. Ayan, say it. Ayan. See there. Okay, Amaro, say it.
Okay, so first we find the intercepts, the x and the y, and then the turning point, and then the shape.
Yeah. Okay, good. Now it says determine the values of x for which g of x times the derivative is smaller than naught. Okay. So this looks like a complicated question, but I promise you it's not that bad. Once you understand what the question is asking, what is g of x? G of x is the y value. Do you guys agree?
Yes.
It's the y value. And what is g of g dash x?
The
Derivative.
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 So they're basically saying to you, which values of x do I choose such that when I multiply the y value of the function with its derivative, will I get a negative answer? So I'm multiplying 2 numbers, and I want to know when they're smaller than 0. what can you tell me about when you multiply two numbers and they must be smaller than 0? What does that mean for the two numbers? And their
Mustn't
sign.
it be
That the one must be positive and the one must be negative.
They must have opposite signs, right? Opposite signs. So the one could be positive, the other one's negative. The other one's negative, the other one is positive. You guys see that?
Yes.
Could you
So in
repeat that?
this, so if you're multiplying two things, and in this case, it's just with the y and the gradient, they want it to be smaller than 0. And when you multiply any two numbers, and if you want those that answer to be less than 0 or negative, one of those numbers must be positive and the other one must be negative. In other words, they must have opposite signs.
Oh, okay.
If they had the same sign, what would that mean?
It would add.
Be
Like it would
positive.
be. Yeah.
Be positive, right? Okay. Now, let's move our finger along the x-axis. Okay. Over here, okay, let's start here. Over here, is my y value positive or negative?
Positive.
And my gradient?
Also positive.
Right. So does that satisfy this?
Yes.
No. No.
No, because they have the same sign. The y value is positive and the
Sorry.
derivative is positive. Okay. What about here? At the turning point?
No.
The y value is?
Positive.
It's 0. It's at the turning point. It's on the x-axis, x-intercept. The y value is 0, right?
Yes.
And
Yes.
the derivative is?
0.
So what does that mean? It's not smaller than 0, so it doesn't count, right?
Yes.
What about here? What's my y value?
It's 2.
It's positive.
It's
Yeah,
yeah.
it's
So we were focusing on if it's positive or negative. So it's positive. And my gradient?
Negative.
It's negative.
Do you guys see?
Yeah.
The one's positive, the other's negative. So we know so far that when I choose an x value that is below here, it works, right? It works. It works. It works. It works. It works. Until okay, actually, let's stop. Okay, what happens here?
It's positive.
The y value is positive and
The
the
gradient becomes
Both is
positive.
positive.
so therefore is it correct? Is it the statement satisfied?
No.
No, because both is
No.
positive.
Right.
No.
And what about here?
Yes.
Who's going to explain this one to me? When x is
y-
below 0.
The y value is negative and the gradient is positive.
Right. So what does that mean? Is it satisfied?
Yes.
So that means that all this is satisfied to negative infinity. And all this is satisfied. So x would be greater than 1 and smaller than 3, and x must be smaller than 0. No. No. Smaller than 0. Do you guys see that?
Yes.
Do you see how, if you understand what it's asking, it becomes so much easier? Does everybody understand or want me to say it again? I could say it again, just see everybody understand.
It's fine.
Ayan?
It's fine. I understand.
Okay. Nafisa?
I get it.
Okay. So these are the questions that students struggle with. And I think it's mainly because they don't understand what is the question asking. And once you can start to visualize it, it becomes so much easier. Okay. The same thing with this next question. The next question says, for which values of k will g of x equals k have 3 real and unequal roots? Does anybody want to break down this statement for me? This is maths. Who wants to translate it to English? Anybody want to try? We've done similar ones to this before. Rivka, do you want to try?
I don't think my wording is right.
Try, just try.
But
Just
like,
try.
isn't it like at the constant point where there's 3 points on the graph, like the horizontal point.
Horizontal
Wait,
point is, can a point be
constant.
horizontal?
No, it's a
Con-
line, horizontal
that
line.
that
Yeah,
line
Aaron.
where there's 3 points on that touches that's on that line. Does that make sense?
You are correct. 3 intersections.
There we go. That yeah.
Yeah, so you understand, but I just want to just make it, maybe refine it a bit, because the question is saying g of x equals k. That's what the question is saying. What does that even mean? My first question to you is, what is k?
Constant.
It's a number, right?
Okay.
Just
Yeah.
a number. It's not a variable, it's a number. Now, the way to approach this is to think of k as a function. So maybe saying like h of x equals k, or something like that. And what happens when you put 2 functions equal to each other?
It intersects.
You're finding the intersections, right? You see,
Yeah.
when you put 2 functions equal to each other, g of x equals k, you're finding where g of x equals k. But isn't that's the equation? Where does g of x intersect with k? But now my question to you is, what is the graph of y equals k? Naima?
It's a horizontal line.
Great. How did you know it's horizontal line?
Because y is equal to a constant.
Perfect. So whenever y equals a constant, it's a horizontal line. And here, y equals k. But you guys told me that k is a constant. Therefore, y equals k is a horizontal line. Therefore, when they say, where does g of x equal k, what they're actually asking you is, where does g of x, which is this graph, intersect with a horizontal line? And this horizontal line, how I can only move it up and down, right? You can't move a
Yes.
horizontal line to the side. You can only move it up and down. So if I choose k to be 6, it's over here, right? Do you guys see that?
Yes.
If I choose k to be 5, it's here, right?
Yes.
If I choose k to be 0, it's here. I choose k to be -2, it's here. So when they say, find the values of k such that g of x equals k has 3 real and unequal. Unequal just means different, unique. Think of unequal as being unique. So how many roots when k is -2?
1.
1 and -1?
1.
0
2. 2.
and
3.
here?
3.
3.
3.
3.
1. 2.
1.
3.
2.
3. 3. 3.
So you guys get it now.
Yes.
You guys get it now. So what's the answer?
The answer, isn't it?
Y must be isn't it y must be more than 0?
Not y, k.
Sorry. K must be more than 0 and less than 4.
Less than 4.
Hey, it's done. Do you see, these questions are not difficult. It's just you have to understand them. You see, if you just have to understand the question, and if you that's why I feel like students are being deprived. Like so many students are being deprived because they're not being taught how to understand these questions. Because how can you answer the question if you don't understand it? And that for me is the saddest thing. Anyway, it's okay. For which values of x will the graph be concave down? What do we understand? What's the mathematical translation of concave down? Rivka?
Me.
Anyone? What's the mathematical
With it-
translation?
The double derivative.
With
Yes, you're halfway there. So remember, double derivative is just
So
second derivative equals 0.
no.
The point of inflection.
No.
No.
Concave down. Ayan,
Is the point of
negative.
Is the second derivative greater than 0?
the other one.
less than 0?
Less than 0, yeah, less than 0. Okay. And concave up?
More than 0. Wait,
More than
equals-
0.
Yeah.
I think I'm gonna quiz you on all this calculus stuff. Because it has to be automatic. It has to be automatic. I say to you, boom, concave up. You must be like, second derivative is greater than 0. If I say, boom, point of inflection, second derivative equals 0. If I reverse it and I say to you, second derivative equals 0, point of inflection. Second derivative greater than 0, concave up. Derivative equals 0, stationary point. Okay, so that's the level. That's where we're going to be. Okay, inshallah, that's where we're going to be by the end of the year. If there is an end of the year for you guys. Anyway, so now values of x is which values of x will the graph be concave down? So you just make the second derivative smaller than 0. However, there is a graphical way of doing it. And I think because we've sketched the graph, we can do it graphically. And the graphical way is to say, if it's concave down, second derivative is smaller than 0, but also the graph is below the tangent. The graph is below the tangent. So what does that mean? If I draw tangents here, right? What happens here, by the way? At that dot.
The
Point of inflection.
Yeah. So what's the definition of point of inflection?
Second derivative equals 0.
Okay, but how if you were to explain to a layperson like what is
The
It is
change
when
from
concave
concave.
changes.
yeah, so like a simple way to say tangent goes from being above the graph to being below the graph, or below the graph to above the graph. Okay, so concave down is when second derivative is smaller than 0. Okay,
Yeah.
or the graph is below the tangent. Where's the graph below the tangent? Which x values?
Isn't it from
0 on
3? From 3. No. 2?
So, yes. What about 2?
So when x is equal to 2.
Is that where it's concave down?
Yes.
Isn't that where it's the point of inflection?
Isn't it less than 2?
Less than 2.
Yeah.
Because guys, look here, if it's less than 2, the graph is below the tangent.
Yes.
Whereas when it's above 2,
More
the graph is above the
of
tangent.
the tangent.
So that's how graphically you can work it out. But using calculus, you can just find the second derivative and see where it's smaller than 0. And you guys
so
know how
I
to
did
solve
that.
Yes. Did you get 2? Actually, I'm just assuming that it's 2.
Yeah, so I got 2.
Yeah. And then you must say, but you made it equal to 0. You must make it smaller than 0. So what is the second derivative? What was the second derivative? We said it was 3x squared plus 6 minus 12x plus 9. Sorry. Minus 12x plus 9. Plus 9. So it's
Is
going to
equal
be 6x minus
6x
12, right? Is smaller than 0. Do you guys see this? That's the derivative. Here's the second derivative. But we must make the second derivative smaller than 0 because we want to find when it's concave down, which means that 6x must be smaller than 12 and x must be
Smaller than 2.
So do you guys
X
see it's
must
the
be less
same?
than 2. Yeah.
Yes.
So both ways work. But let's say they never gave you the graph. Then you use this. Okay? If they gave you the graph, but never gave you the equation, you use this. Do you see?
Yes.
So what you're doing now is you're developing skills. You're developing tools. So depending on the information that they give you, you have different options at your disposal. You see? So if I asked you how can I find when it's concave down? Oh, you can say, oh well, Elias, you could say the second derivative is smaller than 0, or you look where the graph is below the tangent. Or
Okay.
Elias, where's the point of inflection? You can make the second derivative equal to 0, or you can find the turning points and half them. If the turning point is 1 and this is 3, what's halfway?
2.
2. You guys see that? So there's different ways of finding the same answer in maths. And if you can master the different ways, then it doesn't really matter which question they give you because you have different tools. But if you only knew this, right? If you only knew the second derivative is smaller than 0 and you never knew the graph, then if they only gave you the graph, you couldn't solve the question. Do you see what I'm saying?
Yes.
You see. So that's why it's so powerful in maths to have an approach to multiple questions, to multiple concepts. Okay, so that's why we make the concept videos. Okay, so let's do the next question. What's next? What do we have? Oh, there's 8 notifications. Oh no, it's not for this. Okay. Okay, what's next? Oh, okay, there's the optimization. Okay. Uwais, have you done calculus yet? I see you've just joined.
Yeah, we did a bit.
Okay.
Not a lot.
Okay.
We haven't finished it, but some.
Okay. You will just watch the concept videos.
Yeah, I started with it.
Okay. The length of the rectangular box is 3 times its width, and the width is x. So what is the box? The length if the width is x. the box, the rectangular box is, the length is? If it's 3 times, it's just going to be
3x.
3x, right? So from reading the question, I already know it's 3x. The total surface area. Someone say something? Oh no.
No, I just cleared my throat.
Oh, okay. The total surface area is 450. Sorry. Total surface area is 450. So when I read surface area again, it's just like I told you. If you read surface area, think to yourself, okay, what's the equation of surface area? Do you guys see what I'm saying? Because this is English. I want the maths. So what's the math of surface area of a rectangular box, a rectangular prism? Does anybody know the formula? Does anybody know the formula for the surface area?
Not offhand, no.
So you can break it up into pairs, right? So in fact, the nice thing with this one, because it's a rectangle, you can have this, and then you have the one on that side, which is the same, right? And those are the same, right? So you can say the height. We could say x times the height. What?
Or you could say like 2 times that area plus 4 times the other area.
Yes. So what is this area here? Let me shade it in. Well, how can we express this area here? How can we express this?
3x.
3 times x.
So it's 3 times the height.
Oh, 3x times
Mike's, okay. Yeah, three times the height, right? 3x times the height.
Yep.
But times 2. Because on the other side.
2 sides.
Right? 3x times 6x times the height. And now the top one.
It will be 3x times x.
Which is
4. No,
3x
the
squared.
colors, yeah. 3x squared, right? Okay, so I'm not an artist, but just bear with me. So it's 3x squared, right? Times 2.
Yes.
Times
Yeah.
2. Times
It'll be
2. So it's going to be 6x. It's going to be 6x squared, right?
Yeah.
That's the surface area. So do you see, just from them telling me this, I've already got an equation. Do you see that?
Yep.
And they're telling me the
Yes.
surface area is what?
450.
450.
So I already have an equation just from the statement. We've got a nice equation. Okay. Now they say express the length, which is 3x. What do they mean length? Oh yes, of course. Okay. The length is just 3x. Okay. And it's just 3x. 3x. Okay. In terms of x, what do they mean by that? Oh no, we've done that. Sorry, we've done that. It is 3x.
Yeah, so it is 3x.
Yeah, sorry. That's
We did a whole extra step there.
we ahead of the game. Okay, so now number 42. Show that the height is that. So how can you show that the height is that? What could you do maybe?
Make h the subject of the formula.
Of which equation?
The one that we
The one that we got.
solved. Found
See
out.
that? So you see that before you even read the question, you already had an equation for you. You see
Yeah.
that? But if you
Yeah.
didn't make this equation, then like you read that statement, it's like, whoa, what is this? Like this looks so complicated. But then you think to yourself, oh, actually I have an equation already. Can't I just make h the subject? So that's why when you read these questions, you must know surface area, always think equation. What's the equation? So these are just tricks that will make your life so much easier. So okay, let's solve for h. So it's going to be, let's first take the x squared over, so it becomes 2xh plus 6. Actually, let's take
8xh.
Let's take, it's 8xh, right? Sorry, it's like terms, algebra, equals 450 minus,
6x squared.
right, and then what does that mean for h?
Divided, h equals to 450. Sorry, that's my mark. Okay, I'll switch off. But it's 450 minus 6x squared over 8x. Okay, bye.
Okay. Right, okay, I don't know what's going on there. Okay, 8x. Do you guys see that?
Yeah.
It's right there. It's right there, okay? Now it says, show that the volume of the box. Ooh, what's the volume? The volume of the box is that. What's the equation for volume of the box? What's the equation for volume of the box?
Length time breadth time height.
Right. But what's the problem with this, especially when it comes to calculus? What's the problem with this equation? Like, why is this problematic?
Is it because we don't know the height?
It's problematic because you have 3 variables.
Oh yeah.
So the problem with calculus for high school, okay. In the calculus that you've been taught, you can only differentiate when you've got 1 variable. Okay. So that's why you have to try and write all of these in terms of 1 variable, such as x. So what did we say the length is?
3x.
3x.
What did we say the breadth is?
X.
So that's x squared. And what did we say the height is?
H.
That thing in 4.2, that whole fraction.
450 minus.
X squared over 8x.
So do you guys see how we've taken an equation, a formula with 3 variables, and we've converted it to 1 variable? Do you see that?
Yep.
So now you can differentiate because you've got 1 variable. So let's multiply out. What we can actually just cancel this x over here quickly. So it becomes yeah. So what's 3 times 450?
Wait,
1,350.
Yeah.
Yeah.
what did we cancel
Oh,
The X.
with what?
With the
yeah,
bottom x.
Oh, the
There
3x
was an
squared.
X
Okay.
squared and
Yeah.
yeah.
Okay,
Yeah.
thank you.
Okay, sorry. Yeah. 3 times 450, 1,350 divided by 8, I assume is 675 over 4. Yeah, it is, yeah. 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 X minus 18 or 9 over 4 x cubed. That's the volume. Okay. Which is that?
What happened to that?
Okay, I skipped a few steps there. Let me just so 3x, what's 3x times 450? It's 1,350x, right?
Yes.
Yeah.
Minus 18x squared. Minus 18x squared cubed. Over 8. But we can divide the 8 out by each of these terms. So what is 1,350 divided by 8? If you type it in, it becomes
6/4.
75 over 4x minus 9 over 4 x cubed. Does everybody see that?
Yes.
Yeah.
Now it says determine the value of x that will give you a maximum. What are we thinking?
The derivative is equal to 0.
Right. Okay. Okay. Why?
Sorry?
Why derivative equals 0?
Because they're asking for the maximum. So the maximum value is the x value of the turning point.
Just be careful. There's two things. The x value of the turning point is not the maximum. The x value is just the x value of the maximum, right? We don't know the maximum yet. We just know the x. We can work out the x value that when you sub it in gives you the maximum. Do you see that?
Yes.
Like when you solve, you get a particular x value like 3. This 3 is not the maximum. This is the x value that when you sub into the volume formula, that will give you the maximum. However, we'll probably get 2 answers, right? Because this is a square. But let's just see here. Let's just see here if maybe we should see what's going on here. Who wants to do the derivative of this for me? Always, do you want to try the derivative?
Oh no, it's okay.
Let's try. Have you done the derivative yet? Taking derivative.
Yeah, but we haven't went like far.
Okay, fine.
Just the basic examples.
Amara, you asked me a similar question this earlier. Do you want to try?
Yeah, so isn't it 1,350 minus 54 x squared?
Wait, this is the equation, right?
Oh, sorry.
Yeah.
I was looking at the other one. So it is 675 over 4.
Yeah, but what are we looking for? What do we write here? What I write here?
Oh, so it's v dash.
Yeah, v dash. Yeah, sure. V dash. Oh, yeah.
Is it t? I'm not really sure.
No, whatever's. Yeah. An easier way is just to write dv by dt.
Oh, okay.
Remember, whatever you write here is there, and if it's sorry, dx. Nonsense. Dx. So you were saying, Amaru?
Okay, so it's 675 over 4 minus 27 over 4x squared.
Great. And what about that? This is the derivative.
So we make it equal to 0.
Correct. Great. Yeah.
And
so what's next?
The x we can bring it to the other side.
Yes, sure. Okay, so it's 27x squared over 4 equals 675 over 4. Yeah, sure. What can we do next?
Don't you bring the 4 over?
Yeah, you can actually
And-
cancel the 4s
Yeah.
because you're multiplying by 4.
And then
Okay.
over
On both sides.
675 divided by 27 squared.
Okay, and then
squared
x equals
5.
uh
Oh, what's it?
Plus minus.
Plus
Plus
minus
minus
5.
5.
always
Ah,
be
yeah.
careful. Always be careful with that, eh? But can x be minus 5?
They ask for the maximum value.
But I mean, just logically, yeah, you can't have if it's
Yeah,
can't
it
have a
can't be
negative.
minus.
Right? Do you guys see that? This is a box, so you can't have a negative 5 length. Yeah. So by process of elimination, x must be 5. So my question to you is 5 the maximum?
No, you sub it
No,
back
you
into the formula.
formula.
Yeah. So what is 5 then? What is this? What is this 5 that I'm writing here? What is it representing?
The x value at the maximum.
Correct. It's the x value. So a lot of students make this mistake. They will maybe find 5 and then sub it in and say, okay, the answer is the maximum. But the question is not asking for that. The question is asking for the value of x that will give you a maximum. They could add question 4.5 and say, find the maximum. You see?
Then you sub
Fine.
in the x value into the equation, right?
Yes, into the original equation, not the derivative.
Yeah.
Okay. Does that make sense?
Yes.
Wait, so for this one, we don't sub it back in.
Because they're not asking for the maximum.
We're only asking for the value of x.
You see? Okay, this is actually a nice question. Okay. What's next? Okay, Rivka. Okay, Ayan asked a question. Okay, nice trick question. So now with these questions, always draw the triangle. The moment they write if sine x equals q, if cos x equals 5, or your brain must automatically tell you, like, triangle, draw the triangle. Okay, so how do we draw the triangle? So we draw over here. We can do that. We draw a triangle, and we're saying that this is 10, and then this is, we're saying that cos is adjacent over hypotenuse, so it's 1, and that must be root 1 minus k squared if we do Pythagoras. Do you guys all see that?
Yes.
Let's make this bigger. So just from this statement, guys, just from that statement, you've got a whole triangle. You've got a whole triangle. Okay. Now, all right. So this one looks a bit challenging, but what I'm looking at now is that when you look at the question, because you guys are in matric, you have to think to yourself, listen here, they're going to use stuff that they've taught us. What are the two concepts you were taught in Trig this year?
Double and compound.
Double and compound, right. So now you have to ask yourself, cos 70, can I create that? Because we don't know this, right? We don't know cos 70 is using the triangle in terms of k, but can we create 70 from the triangle?
Yeah.
How?
80 minus 10.
There we go. Do you guys all see that?
Yes.
Yes.
Okay. So we say cos 70 equals cos of 80 minus 10. And if we apply the cos double angle identity, that's cos 80 cos 10 plus or minus.
Minus.
Plus.
Plus.
Oh.
For cos, it's always the opposite, okay? For sine, it's the same. And do you agree we can work all of this out now? What's cos of 80?
Root
Guys,
1 minus k squared.
root 1 minus k squared. What's cos 10?
K.
Okay. What's sine 80?
K.
Okay. What's sine 10?
K.
1 minus k squared.
Not
Root.
k, root
The
1
square
minus.
root 1, yeah.
Oh, sorry.
So what does this mean? Can we simplify? Can we simplify this one?
I think so.
Isn't it just 2k square root
Yeah, it's
1
just two of
minus?
it. I actually forgot there. I saw that there's actually a whole other part to this. Sorry, I got excited. There's a whole other part. So let us just erase that. But you guys agree sine 70 is going to be the same, right? You just use the sine identities. Let's do that now. So we've got, no, let's just do that. We've got the sine identity, right? So the sine identity says, what's sine of 70 going to be? Sine of 80 minus 10, which is what? What's the sine identity?
Sine, cos, sine, cos.
Yeah, sine, but minus or plus?
Minus.
Minus, right? Okay. Cos 80 sine 10. What's sine 80?
K.
K.
What's cos 10?
K.
Also K.
Whoa. Okay. What's cos 80?
K.
Root 1 minus k
No,
squared.
the root 1 minus k squared.
What's sine 10?
Root 1 minus k squared.
What's root 1 minus k squared times root 1 minus k squared?
1 minus k squared.
Right. So it becomes k squared, open brackets, 1 minus root 1 minus k squared. Okay. What's tan 10?
1
Sine
minus
over
k squared over
cos.
k.
But you can use it from the triangle, right? So what's it?
Root 1 minus k squared over k.
Root minus nasty one here, but anyway. So you cancel the k's, right? And there's your answer. That looks like a marathon there, but do you guys see how all of this just came from the triangle? Do you guys see that?
Yes.
All of the knowledge we gained from answering this question, it all came from the triangle. Okay. So moral of the story, draw the triangle. Okay. So next question says 1 minus 10 over 5. Now, okay, when we see 5, how does that link up with what we've been given? How is 5 connected to the triangle?
Is that the double angle?
Yes. What's okay? So you got 10 there, 80. So isn't tan 5 just? It's half of 10. Do you guys agree?
Yes.
Yeah.
But you guys don't know a tan double angle, right?
No, we only
you guys-
did sine and cos.
You only did sine and cos, yes.
Yes. So can we convert this into sine and cos?
Oh yeah, can change sine, tan.
What's 1 over tan 5 equal to?
Cos over sine.
Cos 5 over tan 5. Sine 5. And what's tan 5?
Sine 5 over cos 5.
You guys will see that. And if you wanted to, you could bring them together. So we have to find what's cos 5. If we said cos of 10, right, is equal to cos 5 plus 5, or 2 times 5. Or perhaps we have to use 20. We have to use 20. Because if it's 20, then we can get the 10, which is what we need. Perhaps that's why they asked us for the first question. Okay, let's just write this down. Okay, so cos 20 equals 2 cos squared 10 minus 1. Do we agree with that?
Yeah.
But they want 5. Okay, let's just write here. Let's change cos. Okay. Cos 10 is equal to cos of 2 times 5, right? Which is equal to 2 cos squared 5 minus 1. Do you guys all agree? Guys?
Yes.
Yep.
And that's equal to k. Isn't cos 10k?
Yeah.
So we could then simplify, and it becomes cos squared 5 equals 1 plus k over 2. Therefore, cos 5 is root 1 plus k over 2. Do you guys all see that?
Yeah.
Yes.
Everyone else? Naima, Nafisa, Rifko, Amaro.
Yeah, I got it.
So we can do the same thing for sine, right? Because we can also use the cos we can say that's this, we can change that to the sine double angle, which is 1 minus 2 sine squared 5, right? And then it becomes sine squared 5 equals k, actually 1 minus k. We'll take it over onto that side, over 2. And therefore sine 5 equals root 1 minus k. Do you guys see that? Must I repeat it again? Must I say it again, or must I repeat?
Yes.
I mean,
please.
okay, so we said that cos 10. So because they asked for 5, I'm just thinking double angle somewhere. And we know that cos 10 equals k, but we could also apply double angle formula. So just so that you guys remember. Does ring a bell? Does this ring a bell?
Yes.
So if I choose cos of 10, then I can either change that to 1 minus 2 sine squared 5, or 2 cos squared 5 minus 1. Do you guys agree? Because it's 2
Yes.
times.
Yeah.
And that means that because this is equal to k, isn't cos 10 k? Cos 10 is k. That means that I can solve for sine 5 and solve for cos 5. And because I have sine 5 and cos 5, I can then find this. Because I said this was just that. Do you guys see that?
Yes.
Yeah.
Yes.
So therefore, cos 5 over sine 5. These are difficult questions. Cos 5 over sine. This is a bit messy, yeah? Cos 5 over sine 5. So what did we say cos 5 is? Is root 1 plus k over 2 over sine 5, which is root 1 minus k over 2. I'm pretty sure you can simplify that. Anyway, minus sine, which is root 1 minus k over 2 over root 1 plus k over 2. Does it make sense?
Yeah.
Yes.
Yes.
Emma? Officer?
Yes.
Yes, it does.
So do you guys see how it all comes back to the triangle? Right? It all comes back to the triangle. So Rivka, your question we've answered already. Actually, I mean, I'll answer it, but there are lots of questions in the bank that I want you to watch. But I'll also just show you my approach. Okay. I'll also just show you the approach. Okay. I think somebody actually asked a very similar question to this. Is this from an Islamia paper?
Yes.
Rivka?
Yes.
Okay, yeah. So because they want A and B, what did we say the rule is, guys? They want two variables, you need to create two equations, right, Naima? I
Yes.
think Naima said it earlier on, right? So you need two equations. So what can we do? So they tell us that you've got a tangent at x equals minus 1, which is y equals minus x plus 3, minus 7x plus 3. So we need two variables, A and B. And because we need two variables, we need two pieces of information. And because we will have two pieces of information, we can have two equations. Okay. So do you guys know of anything? What are do you guys know of any two pieces of information that we can use?
The gradient of the function.
What about the gradient? What's that rule we said? Maro?
Yeah.
What's the rule we said about the tangent?
Oh, so isn't the tangent equal to
The gradient of the tangent is equal to the gradient of the graph at the point of contact.
yes, thank you.
Right. So what does that mean for, so how now use that concept and apply it to this question. What can you conclude from that concept? Anyone want to give it a try? What does that mean?
The gradient of the tangent is -7.
The gradient of the tangent is -7, but more. I want more. Because the tangent is a straight line, right? So it's always going to be -7. But what, I want something more. Rivka, what do you think? Rivka? Okay, she might not be there.
Yes,
Ayan,
yes.
what do you, oh, Rivka, yeah, Rivka, what do you think? Do you listen, do you hear my question?
No, sorry.
Okay. Now I said, Naima mentioned that the gradient of the graph, sorry, the gradient of the tangent is the same as the gradient of the graph at the point of contact. So how can we apply that concept to this question? What does that mean? How can, for this question?
That the one second.
Read the question again. Calculate the values of A and B.
Can't you define so okay, wait, give me a second.
Anyone want to help us?
Don't you sub in the -1 into the equation and then
Which equation?
the ax squared plus, yeah.
Oh yeah.
You can, but you don't have a y value, right?
So can't you find
But
the
you work out the y value.
Fine,
by
or
subbing that into the
You sub in the
y equals
derivative formula.
Say it again.
Do you sub it
again.
in the derivative formula? I
There's
don't
no
know.
derivative formula.
I'm not sure. Can you sub the -1 into the y equals -7x plus 3, get the value, then sub that value into the other equation?
Yes, but well, why are you doing that? What concept are you relying on to make that assumption?
I'm not sure.
that's a grade.
isn't it because he
The
wants to find the
equation
y?
of a gradient is equal.
Yeah.
Amara, you said something?
Isn't it because he wants to find the y?
Yes, but how do you know that y? Well, how do you know you can sub that y into the original equation?
Because at that specific point on the graph.
Because the gradient of the tangent
At
is equal
that point, the
Then
gradient is
it is
equal to the gradient
Negative.
of the graph.
Yeah, you guys are sort of there. The graph touches the gradient at that point. So they share the same point, right?
Yes.
And that point is at -1. So even
Yes.
though you don't know the y value of the graph, you could just sub -1 into the tangent equation. because they have the same y value at -1, right?
Yes. Okay.
And then from there you could get your y value, and then you've got your first equation because you've got an x and a y value. Do you guys agree?
Yes.
Yes.
So when you sub in -1, you get 10, right, for y?
Yes.
So it's -1, 10. Does everybody understand that?
Yes.
I don't want to move on unless it doesn't make sense.
Yeah.
Doesn't make sense.
So do you see how that concept, you're just applying that concept here? Okay. So you can sub in 10, so it becomes 10 equals ax squared plus bx plus 5. But what is x?
-1.
-1.
So a times -1 squared is
A
a, and plus bx.
minus B.
So a minus b plus 5 equals 10. Therefore, a minus b equals
5.
5. So you see how we're doing mental maths here. So this will save you a lot of time in your exams if you don't rely so much on the calculator. So a minus b equals 5. That's your first equation. Now, what's the second piece of information?
Can't you find the derivative?
So you mustn't ask me. I want you to tell me. You see, because in the exam, you can't be like, can't I find the derivative? Can't I do the tangent? Or you must talk to the paper. You must say, I'm going to do this. Yeah, so yeah, I don't want you to ask me, you must tell me. You see, okay? Wants to give it a go?
Okay, so we could find the derivative of f of x and then make it equal to -1.
-1.
Why -1?
Why do you make it -1?
Oh, sorry, the -1, we sub it into the x of the derivative.
Yes.
Sorry.
And what's that equal to?
That will equal to the gradient at x is equal to -1.
Which is, you know it. What's the gradient at -1?
-7.
Why?
Because that's
They give
the
it
gradient of the tangent.
Do you see?
Yeah, I didn't see that.
So you see, it's all the concepts. It's everything is just based off the concepts. So that's why you have to know the concepts very well. So one more time, just tell me, what's that rule of the tangent?
The gradient of the tangent is equal to the gradient of the graph at the point of contact.
And the point of contact in this question is -1. So therefore, the gradient at -1 is -7, which means the gradient of the graph is -7. So that's why Amara was right when she said, make the derivative, which is 2ax plus b, equal to -7 at x equals -1. And then there's your two equations. So, we've got here -7 equals -2a plus b. What can we do to solve this equation? What's a fast way of solving it?
simultaneous.
Yes, but which method?
You add.
Subtraction.
Get rid of the
them.
Got a subtraction. Subtraction or adding?
Don't you add it because it's
Add.
B?
You add
Yeah.
it. Why? What will that do?
Because it's a negative.
It will
It's a
eliminate.
minus B, and you're going to make it a minus B. If you're going to subtract it, then it's going to be -2B. But
Right. So if you add it, it becomes
Okay. Yeah.
it will be
5 minus 7, which is -2, equals minus a. So therefore, a equals
A equals to
Two.
2.
2, and then B is
B.
0.
minus 7,
No.
minus 3.
Yeah.
minus 3.
So, yeah. Okay. Does that make sense?
Yes.
Yes.
Yeah.
Okay. So, Rivka, there are other questions like this in the bank under tangents and calculus, if you want to practice some more. And for all of you, if there's ever a section that you're not sure about, you can either watch the concept videos or go into the bank. Ayan, have you seen the bank? Did I show you the bank? Ayan, did I show you the bank?
In that concept map thing.
Yeah, or you, if you guys will get that message every now and then. Yeah, so you can click this, right? You can click this. So you've got everything you need as a Tutonic student in this message. You've got your concept videos, right? You've got your bank. You can go and ask a question, and then you can sign up for the live session, and then you can also message for support if you have other questions. Do you guys like the new system of asking questions?
Yes, I love it.
I actually
That's
like it.
cool.
It's so much better. Yeah.
Yes.
Because then it's anonymous, and then it's a bit easier. It's also easier for us because then everything comes together to us at the same time. Yeah, and also makes the group less cluttered. So we don't want too many people messaging the group. Okay, so do you guys have any other questions?
No.
Anything that you're not sure about that you would like me to explain? Any concept? You guys are happy for now?
Yes. Yes.